worked as a CNC on the response line in 1998, and eventually became part of what was called Worldwide Advanced Technologies before I left JDE to take a job as an IT director. I actually implemented JD Edwards as a client at that job. Eventually, I came around to being a JDE developer for a couple of years, doing EDI and ETL scripts, as well as AP, AR, and fixed assets applications and reports. Then I went back to CNCs as an on-the-road consultant doing installs and upgrades. I traveled 100% for probably 7 years before I came to GSI 10 years ago. And here at GSI, I've built a world-class database consultancy, and we handle all types of databases, no matter what application uses them. And in addition to leading the database managed services group, I also lead GSI's infrastructure and cloud managed services and our internal IT department. Before I get into talking about JDE performance enhancements, I want to address something I hear asked a lot. Is JDE 9.2 really the last version? And what does that mean for the future of the software? After all, 9.2 was under development in early 2014 and released in October 2015. So the software is 6 years old as of last week. Shouldn't it be time for a new version if it's really staying around for the long haul? The short answer is yes, JDE is here to stay. And don't worry too much about the version numbers. Many applications don't make a big deal out of the version numbers these days, and they just deliver a base application that is continually updated. That's what Oracle's shifting to, starting with the introduction of their continuous improvement delivery model in 2014, which was changed to continuous innovation in 2017, and more recently to continuous adoption. But like many modern applications, JDE 9.2 gets new enhancements, updates, and features in smaller packages more frequently rather than large business disrupting changes once every year or so. So JDE 9.2 will remain the core of the application for a long time to come. In fact, I would be surprised if Oracle didn't drop the version numbers altogether. But look at 9.2's timeline there at the bottom. In 2015 alone, there were 27 updates. And every year since then, the pace of those updates has continued unabated. So far this year, there's been 16 major updates and enhancements alone. The recent announcement that JDE 9.2 will be in premier support until 2032 should lay to rest any fears of JD Edwards going away anytime soon. Now let's talk about database performance improvements. I do want to clarify something. When Oracle says database performance improvements in JD Edwards, they're not actually talking about changing anything on the database. What's happening is that the application itself is being changed to improve how it secures, retrieves, manipulates, and updates the data. Now, there are improvements to the underlying databases themselves, which I'll talk about towards the end of the presentation, but those are done by the database vendors. I suppose the fact that JDE supports newer databases is a performance improvement in itself. But when it comes to data, 9.2 was about improving security. They introduced the ability to get much more granular with security between JDE and the database by introducing data source security. And they deprecated the security nightmare of public grants on the database. They also created the option to get media objects and print queue files in the database. And that moved the last bit of critical production data off of the file system. Now all data, output, and supporting files can be protected by database security, encryption, backups, high availability, disaster recovery. And 9.2 also brought support for SQL 2016, 2019, Oracle 12c, 19c, and a lot of improvements in the features for those databases came with it. And JD Edwards also changed how the application communicates with the database, reducing chatter and really cleaning that up and tightening up the traffic between all the different servers. So let's go on and talk more about that now. The main part of every JDE application, well, maybe not every, but a lot of applications have grids, and they can be simple or complex. A grid might return raw, unfiltered data from a table, and then it's just a matter of displaying it on the web page. I say it might do that, but it's pretty rare for the data to just come in unfiltered. There's always some kind of manipulation going on before the data is displayed on your screen. But one of the biggest performance killers in a grid is when it has to return a lot of data. Talking thousands of rows of data, like when you click go to end or use the data browser, and that can really kill performance. And users can end up waiting a long time for records to show up. And since the grid is populated through shared memory on the web server, you could kill a lot of other users. Now, thanks to the improvements in grid processing, grid loading times have improved anywhere from 9% to 419%, depending on the application. Bringing all those records over is one thing, but how do you reduce the network traffic that is actively going between all the servers? So everyone knows, or I hope you know, that JD Edwards is very chatty. For every click of a button, there could be dozens of requests being sent out across the network to the various parts of JDE, including the database. And JDE normally sent those requests out on demand, and there's a lot of extra baggage that goes along with a single network request, with the headers and footers and things. The housekeeping parts of communication are really stacking up. And as of 9.2.3.4, requests are consolidated, which cuts down on that overhead and greatly improves overall performance. HTTP compression is tangentially related, I guess, to database performance, but the compression does work for the data coming along and makes it smaller. So why would you want to do this? Because very large data sets have a tendency to slow things down for everyone, not just the user waiting for the data, as I mentioned in the previous slide. So by compressing the results and taking out the empty spaces, deduplicating it, the data gets to the destination much faster with a lot less overhead. The overhead of the compression and uncompression is actually really low compared to sending a full-size data set in most cases. Now, this uses the built-in capabilities of the HTTP server to compress and create the payload that is transmitted is much smaller, and that's how you get your better performance. In Orchestrator, of all the capabilities of Orchestrator, retrieving data from Enterprise One tables is the most common and essential feature. Some of the usage patterns entail retrieving data in small bursts. Others entail retrieving very large data sets. For example, to load or synchronize a complete customer list from E1 to a third-party system. So the enhancements here provides some great optimizations to retrieve very large data sets, possibly thousands of rows, and pass the results in the output without taking the system down. And this was added in Tools Release 9.2.5. Okay, now this maybe isn't totally related to database performance, but it is really cool. I like it a lot, and it's one of the last things that really makes JD Edwards move into the high availability world. It is virtual batch queues. In the old days, if you wanted to have multiple queues, you had to. It was really difficult, borderline not possible. And these days, now you have a virtual batch queue. It's basically kind of a listener, and you can have multiple servers behind it. And if one of the servers goes down, if you have a queue batch, then you don't stop everything. The follow-on UBEs get put to the other servers. So it's fantastic. It's load balancing essentially, but it really brings JD Edwards much, much closer to full high availability and reliability, kind of like how database listeners work. Now, there's some pretty cool enhancements to applications that improves how data is handled. One of them is that JDE is implementing the ability to eliminate data conflict for invoices, receipts, and drafts, so that transactions are blocked for update if another user or application is in process of using it. This is how the database also protects data, but because JD Edwards sends things in kind of a multi-part disconnected transaction thing, database doesn't really know how these transactions fit together. So they've improved the application side by making it handle these conflicts. And then they've improved things between asset master and equipment master. The asset transfer program updates the responsible business unit in the equipment master table. This improves the data integrity between asset master and equipment master. They've also simplified the removal of the employee-specific data. Sometimes when you remove an employee's profile and they have related credit card information when they leave the organization, that's been simplified. So if an employee profile is deleted, any data associated is removed as well. And high volume data, they've got a new paging feature. So what that means is instead of retrieving information in rows, it retrieves it in chunks. So it uses memory more efficiently and makes it easier for larger data sets to be brought in. There's also a data request service. This is for orchestrations. You can create orchestrations that get it's for retrieving data from JD Edwards tables and views. The data can be aggregated, some average count. It also it gives you more direct access to JDE data, but it enforces the JDE security. And now there's also some new database connectors to read and write to non-JDE databases using regular standard SQL protocol. JDE's also tackled duplicate records for address books. So when you enter, revise, or upload records, if you activate the duplicate record validation now, the system will issue a warning or an error message if it finds a duplicate entry. So you can really cut down on massive bloat in the address book by enabling this feature. And finally, media objects in the database. As of 9.2.1, media objects are written and read to from the database. And they actually changed it in 9.2.1.4 to give you the choice to store on a file system or the database. A great thing about putting this stuff in the database is that, as I mentioned in a previous slide, all of these objects are now protected by the database. You don't have to have a separate file system holding all this information. And it's just much more secure, and you can integrate your high availability and everything with that. Now, one of the drawbacks is some applications and implementations of JD Edwards depend on these files being on a file system. And that is, it's going to prevent some people from moving to the database, but JD Edwards does include APIs for you to be able to change your programming to pull this stuff directly from the database. I strongly recommend moving everything to the database. You have a lot better protection, and even with point-in-time recovery, you can go back to previous versions. So, but the one kick is that once you put your media objects in the database, you can't come back. You can't get them out and put them back on the file system. So it is kind of a big decision, but it's in my opinion, it's a good one. Right on. Now let's get to the good stuff, the database-specific stuff. And so I'm going to start with Oracle 19c. There's a lot of great things there. Oracle 19c was replaced, kind of took over the 12.2. So 12c had 12.201 and 12.202. Then 18c came out. That was kind of not a real release. It was a innovation release, I guess they call it. 18c was essentially 12.2.0.3, and 19c is pretty much 12.2.0.4. So it's built on the 12c engine, and this is 19c will be supported through 2026 with extended support. So there's some really great new features that you can go through it, and not all of them you might want to implement for every single installation of JD Edwards, but let's go talk about those now. First thing I want to mention is the 19c optimizer improvements. So the optimizer is really cool. It's one of the most fascinating components of the Oracle database, and it's essential to the processing of every SQL statement. And the optimizer determines the most efficient execution plan for each SQL statement based on the structure of the given query, the available statistical information about the underlying objects, the tables, and all the relevant optimizer and execution features. So this is what drives your efficiency on the database side. It decides how everything is going to be run, and improvements to this always has a big impact on performance. So we're going to talk about each one of these in turn on a separate slide, but it's super nerdy, I guess, super detailed, but if you're here to talk about databases, then I think you knew what you're getting into when you got into this session. So let's go. So adaptive query optimization is super cool. It lets the optimizer make adjustments to execution plans at runtime, and it also collects additional information that can lead to better statistics. In the old days, you would have the database would collect and generate this stuff, before SQL statements were run. So you had these your optimizer had decided how it was going to run a query, and when a new one came in, if it didn't have it would just use whatever it had available. Now it can make these decisions when the query comes in. So there's two parts. There's adaptive plans, which focuses on improving the execution of a query, and there's adaptive statistics, which takes that additional information to improve execution plans. So an adaptive plan could be chosen by the optimizer if the query includes joins and complex predicates and make it difficult to estimate, the cardinality. It lets the optimizer defer the plan decision for a specific statement until it gets executed. So it'll execute its chosen plan and then collect statistics at runtime. And by using that, it can detect if the SQL statement is bringing back the same data that it thinks it is. If there's a huge difference, then that plan will be automatically adapted to either avoid bad performance or make the performance better. So the adaptive plans are enabled and disabled using a database parameter called optimizer adaptive plans. It's always recommended to be true, but as with any setting like this, you would want to test it in non-prod to make sure that it's doing what you think it's doing. All right, so this is kind of cool, maybe a little bit scary. Automatic indexing. So I don't know if any of y'all are familiar with Exadata and storage indexes, and even the iSeries has SQL packages. Those are all essentially automatic indexes. So indexes are useful. For most types of workloads, they're very critical for online transaction processing, which JD Edwards is. But finding out what indexes you need is not always straightforward, can cause a considerable amount of manual labor. Index management is really a continuous process, and applications are rarely static. They change in response to changing business requirements. Data volumes change, but there's also less obvious changes in data value distributions and the way the data is organized and processed and accessed. So traditionally, DBAs have been responsible for monitoring performance and deciding where to add, change, or remove indexes in tactical or ad hoc manner. And this approach to index maintenance can cause problems because it's almost impossible to quantify how much benefit there is, if there is even a benefit at all. You could add an index and it could actually make performance worse. So you could end up with a database that has way more indexes than necessary because people are adding indexes over time, and people don't want to remove them because they don't want to cause performance to suffer. So the more indexes you have, the more system resources required to maintain these indexes. Over-indexed tables have less stable execution plans, and because the optimizer has to choose from so many things, and every index is an additional write to the database. So, take the F0911, which is shipped with 36 indexes directly from JD Edwards. So that means every time one record is inserted, updated, or deleted from the F0911, 36 other actions are taken at the same time. And if you add more indexes to the F0911, it just makes it worse. And if you look at the index statistics for some of these tables, you'll see that even JDE shipped indexes are never, ever used by the database. So automatic indexing, come in with that, then you have, it's an expert system that implements indexes based on what a skilled DBA would do. It analyzes the application workload. It identifies queries that will benefit from additional indexes, and then it validates them and then implements them. And the entire process is fully automatic. Now with JD Edwards, obviously, if the database adds an index that's not added to JD Edwards specs, well, it doesn't really matter because JD Edwards, and I've done a whole webcast on just indexes. JD Edwards does not know or care what indexes are on the database. It doesn't matter. You do have indexes defined inside of JD Edwards, but that has no correlation to what's on the database. Now, ideally, all the indexes defined in JD Edwards are on the database, but you can add and subtract and the indexes directly to the database, and JD Edwards would never know. And the reason is because it's not JD Edwards that chooses the index, it's the database that does it. The index information inside JD Edwards specs is only there for development reference, and that's all. It doesn't change anything on the database itself. So automatic indexing, you could enable that, and you would end up with some really cool indexes on there that you would not have to define, nor would you even have to know that they were there. It would just be done automatically in the background. Now, again, with any kind of setting, I would caution, enabling that without a little bit of testing. Even though it is automatic, it is a machine doing the decisions. I'm not saying I don't trust machines. I think this is a fantastic feature, but it should be monitored. And, it's probably going to create a huge benefit, but always take care when adding a new setting. Let's dive back into 19C optimizer statistics. So again, statistics are a collection of data that describes the database and the objects in it, and the optimizer uses those stats to choose the best execution plan. So gathering these stats obviously is a really big deal, as otherwise you have bad performance. And so we talked about the advanced query optimization. So I'm going to move right into the high frequency automatic statistics gathering, which is super cool. As you may know, DBAs know that there's a scheduled job, maintenance job that does gather stats on a regular basis, but sometimes it can't be fast enough because data can change super fast. So you might, if all of your data that you're using currently is all new, it may not be included in the previous stats. So that's why they introduced this high frequency stats gathering. It is separate from the regular maintenance schedule, and it goes in and tries to fill in those spaces where you might have stats that are out of date and you don't have time, or maybe the bandwidth, or you don't have a maintenance window to do manual stats collection. It makes the large, especially large, heavy use tables, it makes those perform a lot better. And there's also histograms, though that's really cool. It tells the database what's in a column, how the data is distributed, and it gives that information to the optimizer to decide, to have a more accurate estimate of what kind of data is going to be returned. Online stats gathering, what this is obviously stats are being gathered all the time, but this online stats gathering is for when a new table is created or data is loaded in a bulk operation. You used to have to gather stats after that happened in order for the stats to be current. But now Oracle creates the statistics as the data is being loaded. So you have accurate stats immediately as soon as it's done. And it's real similar to real-time stats. This is more specifically for create table as select and direct path insert. This was prior to 19C, so this has been in since 11G, but prior to 19C, this wasn't able to be used for conventional database manipulation operations, which is called DML. This extends the stats gathering to all of the conventional type of insert, update, et cetera, to minimize the performance overhead of the stats gathering. So only the essential optimizer stats are gathered during the DML, and the remaining stats are done during the automatic jobs. And finally, incremental statistics. This is not something that a lot of JDE clients are going to benefit from, because this works with partition tables. With partition tables, if some stats need to be updated in a single partition, it would also have to update stats for the whole table, every partition. Now, incremental stats allows the stats to be created for partitions only, and then those can be used to derive the table stats without scanning the entire table. Now, a note real quick on partition tables. The partitioning is a really fantastic feature. It allows you to cut your data up into smaller chunks. This is really great for giant tables like F1 on 11. You could partition your table by month and then also by a hash. And that way, when a SQL statement comes in to look at data, it's only going to look in the partition. So if you have a partition by month, then everything looking for October 2021 is only going to look in the October 2021 partition instead of the entire table, which is normally what happens. It also, every partition, it can be managed separately and they could be put on separate disks. So if you have 7 years worth of data in your F1 on 11 or any table, you could keep the current year's data on super fast SSDs and put the last 6 years on, spinning disks if you want, or a USB drive from Best Buy. It doesn't matter. But to the application, it looks all contiguous. You don't have to purge data. You don't have to take it and put it in another whole database or an archive database or buy expensive archiving software, because partitioning is built into Oracle Enterprise Edition and also into SQL Server Enterprise Edition too. So if you're looking at a huge bloat of data in some of your tables, consider doing partitioning, because it may already be included in your database and you won't have to make any crazy changes to get it purged. All right, this is a really interesting feature, SQL Quarantine. I would say that this is probably not something that everybody would want to do because it kills SQL statements. And I'm not a fan of killing SQL statements automatically. But runaway SQL statements can be a threat to your database. And if something runs away, it could consume a lot of system resources. If you have multiple runaway queries that are running concurrently, using a lot of the database resources, it could slow things down quite a bit. Now that the database resource manager has always offered the ability to terminate a SQL statement, but it doesn't work with repeated execution. So there might be a query that runs over and over again, and every time it always goes crazy and has to be terminated. Well, the SQL Quarantine will actually remember that, and the next time that query comes in, it'll kill that query. Kind of interesting, kind of cool, but the way that JD Edwards works, it has a lot of queries that seem like they're running away, but they're not really. And the way that JD Edwards multi-part transactions work, I would hesitate to use this, but there may be some cases when this could be used. Now, this is a fantastic feature, ignore hints. And if you don't know what hints are, that is when a developer or whoever's writing a SQL statement includes a hint in the SQL statement for it to use a specific, say, for example, use a specific index or a specific execution plan that they've decided is going to work, and that's going to work all the time. But hints are almost always bad in the long term. It's basically someone trying to second guess the database optimizer. And a hint might work great for a little while, but the database changes, the data changes, the table changes sizes, the data comes and goes. There's a lot of things that can happen where a hint can either slowly or quickly go bad and actually cause worse performance than if they had just left it alone. And in the past, you would have to actually go and remove the hints from the statements in order for them not to run. But now you can just turn on a feature to not use them at all. And I honestly would, we don't see this a lot in JD Edwards application because it's all canned and comes from the, it comes to you without all of this stuff, and JD doesn't use hints. But third-party developers, third-party applications can use hints. And if you do that and then leave them in there and you don't have really good documentation on them, then you could be sitting a month or 2 or 3 down the road wondering why this formerly super fast application was now running very slowly, and it's because there's some bad hint in there using out-of-date statistics. So I would turn this on every database, and keep the stop second guessing the database optimizer. All right, now you thought that the rest of that stuff that I just talked about was super nerdy, but this is the Oracle database super nerdy stuff. Try to go through this real quick. A lot of this stuff is fascinating for DBA, maybe not as entirely applicable for GA Dataworks, but it's super cool anyway. So Oracle database can go in memory. There's a couple tweaks to that. If you're using in memory, probably not too rare, not too common with JD Edwards. But previously, if an object was being put into memory, the application could try to access it before it went in memory. That doesn't happen if you set the populate wait function. It'll wait until the object is in memory before it allows an application to access it. And also, the in-memory is able to use the resource manager. So it can give you the benefits of the enhanced performance and automatic management for CPU resource allocation, great stuff like that. Now we have fast ingest data inserts. If you have an application that does thousands of little updates to a database, like an Internet of Things, or even JD Edwards does thousands and thousands of queries and updates in a very short period of time. This is a mem optimized row store, if you're familiar with that. This enables these fast data inserts to, instead of being inserted in real time as they come in, they're collected in a buffer and sent in a bulk operation, which saves a lot of overhead and time. Then we go to the SQL plan management. So we talked about the optimizer before. It uses SQL plan baselines as part of its decisions on how it's going to run stuff. SQL plans, they evolve over a period of time. And in 19C, they evolve a lot faster. So the optimizer can correct any performance problems very fast. And then it enforces better execution plans. We've also got changes to workload capture and replay. So if you're familiar with Oracle Real Application Testing, it's designed to capture and replay activity on a database. Now in Oracle 12c, they introduced containers and pluggable databases where they separate out the database logic from the application stuff. If you had multiple pluggable databases, say you had prod and non-prod, or maybe test and CRP on the same container as two separate PDBs, if you wanted to capture your performance testing on just PY, you couldn't do that. You had to get it for both instances. So now in this new version, you can capture just the information, the activity on a single pluggable database. So that way it greatly enhances the ability for JD Edwards application users to leverage the PDBs. And then finally, I almost wasn't going to put this in here. It's a little bit scary, but it's called max idle blocker time. What this does, if you set a number of minutes, it will look for sessions that have been idle and also blocking for a certain amount of time, and it will make it a candidate for termination. So what happens is you have a session going, it goes idle, and then at some point, another session comes in and needs the resources that it's using. That's what creates a block. So this other session's been idle, but now it's blocking. So now this idle time starts, and if you set it for say 10 minutes, then if there are sessions waiting and the blocker session's been idle for 10 minutes, it'll kill that session. But I wouldn't say that that's probably the best thing to do, because again, JD Edwards has these multi-part transactions. It could create a block, a single application could create a block that just blocks itself because it's trying to do something while it's holding another table or another record. And it could be idle for a while and it would be normal. And if you have any kind of automatic block killer, you could end up with some bad rollback times. You could end up with data integrity issues. If your blocking session has been idle for a while, it's probably going to get killed anyway. but I wouldn't want to leave that up to the database. I'm personally not too comfortable with it, but you may find a use for it in your organization. Oracle Autonomous Database. This is I don't know, people say this is a DBA killer. I don't know if that's true. It's not a DBA killer, maybe a DBA repurposer. It basically takes all the busy work and maintenance and plate spinning that a DBA does and starts to move a DBA more towards a data shepherd or a data scientist that helps figure out how best to run your data, how to make the data useful and run faster for some of the things that the autonomous database may not be able to figure out. So autonomous database, super cool. It it's based on Exadata, so it's either going to run on Exadata in the cloud or cloud at customer, which is basically where they give you an Exadata and you put it in your data center. It's available as of tools release 9.2.4.3 on 19C and on Linux. So the autonomous database, like I said, it's self-tuning. It patches itself. It detects failures and corrects them. It automatically scales up and down to meet whatever workload you have. It includes some machine learning, cool machine learning stuff to figure out, how things are running, how they're going to run, what's it going to be like in the future, and zero downtime, which is kind of something that Oracle database has been struggling with as it relates to JD Edwards. I mean, they do have zero downtime for a lot of stuff, but what the autonomous database, it didn't just come from out of nowhere. Oracle's had autonomous features on their databases and on their appliances for a long time. With Exadata, like I said, it has the storage indexes where it automatically creates indexes. They say Exadata workloads don't need indexes at all because it'll create them on its own. But all these cool features, they had them on different things, different versions and different platforms, and they just rolled them all together into the autonomous database. So some of the cooler things about autonomous database really is the zero downtime. When you patch a database, and as you know, if you have an Oracle database, sometimes it can take a weekend. Not all patches are rolling rack upgradable. So even if you have Oracle Rack for high availability, you still might have to, reboot your database and stop your system. But the great thing about autonomous database is that it will gradually drain your database connections over to, another node as time goes by. And then finally, when it drains all of the connections over to the other node, then it can take down the node and patch it, and then do the same thing the other way for, when you need to restart. This is going to be this lets your application continue. You don't even have to know. It just happens in the background, and there's no manual intervention and no impact on business. In order to get JD Edwards on autonomous database, you have to manually migrate the JD Edwards to the database. You can't autonomously do it, of course, but unfortunately, the autonomous database can't support for JD Edwards if there's unplanned maintenance or failures that require the self-repairing features of autonomous database. You're going to lose JDE availability. And there's a couple other things you can't use autonomous database on shared Exadata. It has to be dedicated. But autonomous database is going to be, I think, probably it's going to be the future for a lot of applications. Not sure how much of it's going to be JD Edwards because there's still several limitations related to autonomous database, but it is an option for you if you're on the latest tools release. All right, and finally, I'm going to talk about SQL Server. I've only got one slide because this is Oracle, but SQL Server is a great option and a very viable and excellent choice for Oracle for JD Edwards workloads. They've made a lot of great, awesome changes and updates in SQL Server 2019. Performance is absolutely through the roof. It's got the intelligent database, intelligent query processing, just like we've mentioned, similar features to Oracle. They can actually support UTF-8 now, which is been a long time coming. SQL Server security is absolutely fantastic. They have what's called always encrypted, and it includes this new thing called secure enclaves. These are dedicated, totally separate subsets of your data that can't be accessed, without separate encryption. So it's super cool. Secure enclaves are really neat, and I highly recommend you looking into those if you have SQL Server. And it has in-place encryption. It improves the performance and reliability of crypto operations. So, which is encrypting columns, rotating keys, and stuff like that. Because you don't have to, previously without the enclave, you had to move data out of the database to do that. Now you can do it all inside the database. There's some great improvements to high availability. You can have more readable secondaries on availability groups. Another thing about security is data discovery and classification. The database can actually go through and discover sensitive data on its own and flag that for you and automatically secure it. There's also a new platform. You can run SQL Server on Linux. There's a few limitations to running on Linux, but none that would really impact JD Edwards. So I haven't seen any clients running SQL Server on Linux, but I think that'd be very cool. And then containers. SQL Server has really embraced the idea of containers. It's actually already kind of built for containers. So it's a kind of a logical progression into containerizing SQL Server. So a lot of fantastic things happening there as well. All right, I just want to wrap this up with, what would I want to see for performance improvements in the future? And this is mainly specific to JD Edwards. And number one, fix extended blocking. JD Edwards has far too many processes that block for ages, and sometimes that's just a normal part of the application, as we talked before. The blocking and it's hard to track down, and there's a lot of it. Many clients have issues with extended blocking, and the GSI actually specializes in fixing that and tracking that down. It'd be nice if it would be fixed in the application right out of the box. Another thing too is orphan session handling. Again, with these multi-part transactions, some way to detect when a session's been idle too long, didn't finish something. If somebody closes out of their browser, there's some kind of network hiccup, find some way to put some kind of check digit on there to say that this session still had some stuff left to do, and that's why it's sitting out here. And if it still had stuff left to do, but the application knows it's never going to finish, like the person crashed out of their application, then send something to the database and say, get rid of that session. Stop index proliferation. This is a big deal. I've done multiple webcasts on stopping this. And as I mentioned before, index bloat happens in JD Edwards straight from the factory. And app development encourages adding indexes for what I think are trivial reasons. And people think that anytime there's a performance problem, adding an index will solve it. This really, I think, comes down to mostly education, but it kind of relates to my second bullet, which is acknowledge that DBAs are required. JD Edwards' documentation is written, and the training and everything is written by other CNCs for the most part. And when it comes to database tasks, you're either told find a DBA, or you're given an inefficient and poorly thought out procedure written by another CNC. I'm not dogging on CNCs specifically. I was a CNC I still am, and I wrote some of the database documentation for other CNCs that people still have even today. And coming into the world of DBA and getting down into the trenches with it, start to realize that, man, there are times, most times, you should really talk to a DBA before you do anything, because you could get yourself in a world of hurt. There should really be a correlation between user activity and OS and DB sessions. One application that does that really well is called Cat Eyes. I'm not employed by Cat Eyes. I don't know anybody who works there, but I really like that app. it grabs a lot of fantastic information that helps track down exactly what's going, who did it, when it happened. And that's not something you get on the database side because there's no real correlation because they're using the JDE user, the system user, which leads into my next one. There's got to be an easier way to create a one-to-one relationship between JDE users and database users. Now, Catalyze is one good example. Maybe they could put some kind of, for each row that's put in, put the username as part of it. They kind of have that on some tables, but not all of them. Talking about better transaction management, this probably won't ever happen, but as I mentioned multiple times, JDE breaks up transactions into dozens or hundreds of separate activities on the database, and the steps aren't correlated with each other. So, maybe if a transaction had a transaction ID that's just for the database, we could use that transaction ID to connect together all of the SQL statements and things that were issued throughout that entire transaction. One of my pet peeves is OMW table and index generation. I know it's really convenient to be able to gen tables and indexes through OMW, but from a data integrity and database management perspective, it's just awful. It's too easy to create a business killing mistake with that tool, and it happens all the time. It happens much more frequently than you think. It's okay in non-prod, but when you get to production, you really want to do that stuff on the database. And I have a whole webcast about it. If you have questions about it, I can direct you to that YouTube video. Another big deal is I wish they would rebuild and improve the platform pack databases. The ones that are included with the platform packs are just not well built. Inconsistent data files. There's multiple data files for some and not for others. The sizes and growth settings are all out of whack, and the database file locations are, it doesn't take it into account the database default file locations that you set during your installation. And the grids and reports, I know you can set the grids to use index columns, but it would be nice if JD Edwards could query databases and force it to send queries using indexes in the order that the columns exist, and flag when a query or a grid is not using the index and have a note saying this is really poor performance. It's not going to get what you want because it doesn't match an index. And finally, the ability for JD Edwards, the ability to recognize and leverage advanced database features as part of the application. For example, indexes. If you want to create a index in SQL Server that has included columns, you cannot define that in JD Edwards. If you want to create a function-based column, you can't define that in JD Edwards. So if you have these custom columns, there's no way to put a placeholder in the application for that. And maybe you don't need to define them specifically in the app, but if you could have something in the specs where you could say, this is a special kind of index, don't override it when you do an upgrade, that would be awesome.
All right, that is the end of the presentation. Let me go back to my final screen. If you guys want to get in touch with me, anybody here, you're more than welcome to email me at bill.rem@getgsi.com. Otherwise, I'll turn it over now to Brooke for any Q&A.
All right, one second, Bill. All right, I just see it says, yes, please, concerning the YouTube link for table index generation.
Yep, I'm looking that up now. I'll shoot that out as soon as I find it. The GSI YouTube channel has got all of my database videos on there. I'm looking this up, see if I can find that specific one. So if I don't get this back to you here shortly, just shoot on over to the GSI YouTube channel. It's all of the videos that I've ever done. Well, not all of them, but most of them are up there. And there's a lot of cool stuff related to databases. But I'm right now in the middle of trying to find that for you.
I just sent the YouTube link to our YouTube channel in the chat. Bill, can you hear me?
Yep, I can hear you.
Okay, cool. Thank you. And just a reminder as well, there is the link that is to our YouTube channel. And then also there is a link that I will chat out again to enter a drawing for a $50 Amazon gift card. And I'm just going to wait for Bill to do that. And if you do have any other questions, feel free to enter those in right now as we wait. And we appreciate you guys all being here.
Thanks, everyone. Shoot me an email. Let me type in my email. I don't want to keep everybody too long. If you have any questions, and I'll give you the link to that information just after the fact, so you don't have to hang around waiting for me to click around on my stuff. All right, and that's if that works for everyone, then I think, Brooke, we're good to go.
All right, thank you guys. Thank you so much, Bill.
Welcome. Thanks for coming, everyone.
All right, have a great day.